There are a few different methods to sizing piping in Revit. You can simply change the size of each pipe segment as you sketch pipes, or you can size the piping after it has been created. In this model, there are two piping systems that already have piping laid out. However, the piping has not been sized. As you can see, the condenser water supply system appears as blue, and the condenser water return system appears as red. In this example, we will compare automatic pipe sizing to manual pipe sizing. I'll zoom into the north portion of the building. When designing, different designers have different preferences. But you may wish to create working views in which you place tags with certain information to help design, and plotting views with tags that you need for documentation. For example, when sizing pipe, it is useful to have the flow to each piece of equipment readily available. You may have a table listing the water flow to each heat pump. You could also place a tag on the mechanical equipment listing its flow. In this case, I can select a pipe segment to see flow information, or select a heat pump to see how much water flow it needs. For example, when I select Water Source Heat Pump 1-14, in the Properties palette, you can see the water flow under the Mechanical section. When I select a pipe segment, in the Properties palette, you can see the flow information under the Mechanical Flow section, such as the flow, Reynolds number, flow state, and velocity. Let's begin by sizing some of the condenser water return segments. I will select the horizontal pipe segment connected to the cooling tower. Looking in the Properties palette, I can see that the flow is 168 GPM or 10.64 liters per second in the metric file. There are also a few methods to sizing piping in general, such as by flow, friction, velocity, or some combination of these. There are several charts, tables, and sliders that are used to size pipe. I'll use a standard pipe sizing chart. In this example, I'll use a head loss or friction method at 2.5 feet of water per 100 feet for imperial units, and 245 pascals per meter for metric units. I'll also make sure the fluid velocity in the pipe does not exceed 4 feet per second for imperial units and 1.2 meters per second for metric units. For this pipe segment with 168 GPM or 10.64 liters per second in the metric file, it appears that the pipe diameter should be 4 inches or 100 millimeters in the metric file. This is actually the diameter at which the pipe was created. However, if you needed to change the diameter, you could simply do so by changing it in the Options bar or Properties palette. Also, if you need to select all of the pipe segments and fittings up to the next branch in order to change the diameter, press the Tab key to highlight that portion of the system, and then click to select the elements. Realize that you can change the diameter of both pipe segments and fittings when they are selected. Let's move over to another portion of the system. I'll pan over to the long vertical pipe segment in the corridor. With this pipe selected, I can see that the flow is 108 GPM, or 6.84 liters per second in the metric file. Looking at a pipe sizing chart, it appears that the pipe diameter should be 3.5 inches, or 90 millimeters in the metric file. I will not change this diameter though. I will use the pipe sizing tool to see how Revit sizes the pipe. I will click in blank space to deselect the pipe and then zoom out. With the pipe sizing tool, you can size multiple pipes in different systems at once. To select all the pipes in both condenser water supply and condenser water return systems, I will hover my cursor over the cooling tower, press Tab 3 times to highlight all the pipes, and then click to select them. When I do, the ribbon actually changes to a multi-select contextual ribbon, and there are several options. In the Analysis panel, I'll click Duct Pipe Sizing. Revit displays the pipe sizing dialog since I have pipe selected. You can use the tools in this dialog to choose how you want Revit to size the pipe. Also, realize that Revit will use the sizes available in the mechanical settings to size the pipe. So if there are certain sizes that you do not use when sizing pipe, you will want to turn those off. There are actually two sections in this dialog: Sizing Method and Constraints. Under Sizing Method, you can expand the drop-down and select the method you want to use. The available options are friction and velocity. I will choose friction. Then, in the field next to it, I'll set the friction to 2.5 feet per 100 feet, or 245 pascals per meter in the metric file. Also, realize that the radio buttons below the Sizing Method drop-down are available. For example, with friction selected, you can choose AND to use both the friction and velocity methods when sizing the piping. You could also select OR to use both methods. However, with OR selected, the size of the pipe is allowed to break either the friction or velocity rule, but must comply with one. Since I used both to manually size the pipe, I'll choose the AND radio button. Then I'll set the velocity to 4 feet per second or 1.2 meters per second in the metric file. In the Constraints section, you can expand the branch sizing drop-down and choose Calculated Size Only, Match Connector Size, or Larger of Connector and Calculated. I will select Match Connector Size. Below the drop-down, you can choose to restrict size, but I will not select this option. With all the desired options selected, I will click OK to let Revit size the piping. Once Revit has calculated the pipe sizes, I can select each pipe segment and we can compare the size to our previous results. As you can see, the sizes that Revit came up with match the sizes that I came up with using a standard pipe sizing chart.